Hi all, this is Tech Guru, and I wish to start my videos on YouTube using my first video that will be on Creo. Creo is a 3D parametric software which is used all over the world. Today my tutorial will be basically to differentiate what is the main difference between a 2D CAD software and a Ptc Creo. Okay, there are many softwares like Creo in the market, 3D CAD softwares, but we need to understand what is the major difference. If somebody asks what is the difference between a Creo software and a 2D CAD software, okay, you should be able to answer to them, and that is what I'll be trying to do today. Okay, very first thing is there are 5 to 6 parameters or concepts which differentiate Creo or any 3D CAD software, 3D CAD parametric software from a 2D CAD software, and those 5 parameters are first is solid modeling concept. This is one parameter. This is one concept which differentiates 2D from 3D softwares. Then comes feature based concept. Then comes parametric concept. Then comes associative concept. Then comes model centric concept, and the last, which may not be a differentiating factor, but this is something that exists in every 3D CAD software, and we will be dealing with this as a basic Creo parametric file extension. Okay, so these are the 6 concepts which differentiate a 3D parametric software, 3D CAD parametric software from a 2D CAD software, and which is also involved. These concepts are also a part of Creo software, which is nothing but a product of PTC Parametric Software. Okay, and so what is a solid modeling concept? We The first concept in the list of these concepts is solid modeling concept. Solid modeling concepts is that if you go to a 2D CAD software, okay, when you look at the drawing, it if it is a simple model, it is very easy for you to visualize how a model may look when it is manufactured. But if the geometry of the model is very complicated and there are a lot of views on a 2D CAD drawing, okay, it will be very difficult for people to understand or visualize how actually the model may look after the model is manufactured. Okay, then in this case, softwares like Creo play a very important role. What we actually do is we conceptualize or visualize the model before it is manufactured, in or put into mass production. In this case, 2D CAD softwares, 3D CAD softwares have a edge over 2D CAD software. These are the lists. These are 4 points under solid modeling concepts. Solid modeling concept criteria, which makes a Creo software more advantageous over 2D CAD software. That is, one is realistic 3D visualization. That is, you actually visualize your part, whether it can be a nut and bolt, whether it can be an aeroplane, it can be a train, it can be a car, whatever. You actually model it. Okay, you see it and come to know that this is how your model is going to look once your part is manufactured. Okay, and then comes prevents costly prototype manufacturing. If you want to make a prototype, okay, if you want to make a prototype of a nut and bolt, it may be very cheap. But if you want to make a prototype of a car, if you want to make a prototype of aeroplane or a train, okay, the cost is very high. You imagine putting a lot of money only to make a prototype to test it, and then getting results from that prototype test and then making an actual model. You'll have to spend crores of rupees in it. Okay, sorry, you'll have to put a lot of money in it. So this is where CAD softwares play a very important role. The 3D CAD softwares like Creo play a very important role. Okay, they tell you exactly how it looks. Okay, and what are the what are the changes that you can make to it before the actual part is manufactured. Then comes informations like mass of the model. It will be very difficult. Sometimes it may be difficult. This may be a very important criteria. How, what is the actual mass of my component or my machine before I actually make it? Okay, so 3D CAD softwares allow you to not only model a machine or a component, it allow you to add material to that particular model, okay, to that particular 3D CAD model, and using the geometry that has been created, the software will tell you the exact mass of that model, okay, and center of gravity. Where exactly is center of gravity? What is the surface area? Okay, so these are some of the advantages. For example, this is a simple model of the board. Okay, if you go to file, okay, prepare, then model properties, here you are adding the material steel, okay, then when you go and click on mass properties, it will give you density is directly taken from the steel, volume, mass, area, and center of gravity, where it lies, वगैरह everything with respect to your coordinate system, default coordinate system, everything is obtained over here. Okay, this can be a great help to a manufacturer who is manufacturing bigger assemblies, okay, and mass. We know that this word is all about optimization. If a machine is overweight or it is very high in mass, so the machine designer can think where all he can reduce the weight of the components, so that he can bring down the weight of the entire machine before actually making the machine or putting it into production. That is one. Then enable study of limits, fits, and assembly purposes. What happens is nuts and bolts here, limits, fits, and limits and fits are very important. Okay, because we use nuts and bolts to fasten two components, and everything is based on what is the tolerance between the inner diameter of the threaded portion of the nut and outer diameter of the threaded portion of the bolt. If it is not proper, then the nut and bolt may not properly do, function properly. In this case, again, solid modeling concept plays a very important role. So these are the important points, like realistic 3D visualization prevents costly prototype manufacturing. You get accurate information regarding mass of the model, the center of gravity, and surface area. Enables study of limits and fits for assembly purpose. So this is one concept in 3D CAD softwares like Creo. What is the other concept? The other concept is feature based concepts. Okay, now let's understand what is the feature based concept of a 3D model. Okay, what happens in this is, this feature based modeling is that a model is created with one feature at a time. Okay, the feature piles up over the other in such a way that the first feature always appears at the top of the list, and the feature later added show up in the list depending upon their added sequence. The list of the features in their added sequence appear in the model tree. Okay, now every 3D CAD software has this feature. What it happens is, you use simple features like uh, you can say extrude, revolve. Here you have extrude, revolve, sweep, different concepts, different what I can say tools to build your model. Okay, here I have used extrude and revolve and chamfer as the different features to build my bolt model. And feature based concept here, what it tells you is that it gives you the list of all the features used in its hierarchy, which feature came first, which feature came second, okay, which feature came third. It tells you. And this is one advantage of a 3D CAD model, 3D CAD software over a 2D CAD software. 2D CAD software does not tell you how a model is built. If you want to change the model later on, you can't do it, and it's a lot of time consuming work. Okay, so these are all called as features. Extrude is a feature, revolve is a feature, sweep is a feature. We will deal with this in our later tutorials, how extrude is used, how revolve is used, how sweep is used, how hole, rounds and chambers are used, okay, to make these features. So this is feature based concept. We have a lot of features over here which end up building a model. Here is the model of a bolt where I have used extrude as a feature and revolve as a feature to build this nut. Okay, so this is what is meant by a feature based concept, okay, where we have features. Then let's go back. And what is a parametric concept? We call Creo as a parametric software. Okay, what is parametric software? What people say parametric, but what is actually a parametric software? See, when you look at this model as an engineer, we all know that this model cannot be designed without some preliminary requirements. Okay, what are those preliminary requirements? We need to have dimensions for creating this head of a bolt. We need dimensions to create this shank. We need dimensions to create this chamber. Okay, so automatically the factors that are responsible for designing or manufacturing of a component falls into parameters. Okay, parameter list. So dimension becomes a part of a parameter, may not be a parameter itself, but a part of a parameter, all those factors which are responsible for creation of this model. Then comes other factor called as parameter itself. Okay, now what it is, this model has been created. Okay, now who has created this model? The name of the engineer. Automatically it gets attached with this model. That is one parameter. What was the date on which this model was created? That is one parameter. Okay, then what is the name of this component? That is one parameter. What is the description of this component? This is a M10 bolt. That is one parameter. Okay, and then similarly mass can be a parameter. These are this parameter itself, these are some of the criteria that differentiate this model M10 bolt from another model. Okay, so if parameter changes, the um, CAD model may change. For parameters for M10 may be different, for parameters for M9 bolt or M8 bolt may be different. Okay, so that is one parameter. Second thing is relations. Excuse me. Second thing is relations. What is relation? Guys, bolts and nuts are not simply manufactured in the factory in a heavy manner. Okay, everything has equations, everything has design criteria. Okay, I will show you. These are some of the formulas which are used to design a bolt or a model. Okay, these are some of the criteria which are used to design a model. Diameter of the bolt, shank length, then length of the bolt, okay, radius of chamfer, what is the angle of the chamfer. So these, using these equations, we have created this bolt. So this also becomes a part of the parameter. So a 3D CAD software, a 3D CAD software like Creo uses all these parameters to create a model and save the information. Okay, so this is the advantage that you have in a software like Creo over 2D softwares. Okay, so that is parametric software, parametric concept. What is associative concept? This is a very interesting associative concept. Is one more very interesting uh, concept over here. What is it? See, guys, this property is one of the most important and advantageous one of the CAD softwares like Creo. What happens is, in this concept, any changes made in this part is auto captured in the assembly, and that in turn is captured in the drawing. In case the changing part is used in the drawing and assembly, saving a lot of time for assembly and drawing update. Okay, now we know that in a 2D model, okay, let us say that you have created a bolt drawing, okay, and that bolt you have used in an assembly. Now you decide that I want to change my M10 bolt in M10 bolt to M9 bolt in the assembly. If you have a drawing for M8 bolt or M9 bolt, it's good. If you don't have, you have to create it. Okay, then you have to change it manually in the assembly and change it manually in the drawing. Okay, in the 2D assembly and drawing. But what happens in a software like Creo? Okay, it's this is one of the beautiful thing that you can admire over here. Okay, what is it? That if you have created a drawing and if you have created an assembly using bolt and nut. Okay, now if you change this M10 bolt from M9 bolt in the assembly. Okay, or let us say you have made some changes to this part in the part level. Let's open this and demonstrate that. Okay, now here I do not have a round, so what I'll do is I will go ahead and give a round over here. Now this is the change that I have made at part level. In 2D drawing, when you make any changes to the part level, you have to manually capture it in the drawing of the assembly as well as part, which is a tedious work. But in a CAD software like Creo, these changes are automatically captured at assembly level as well as the drawing level. You don't have to spend extra time in doing this. You can see this was done automatically. Now let us say that I want to make a change at the drawing level and I want that to be reflected in my part level and assembly level. Let me change this M10 bolt value to M9 and then I regenerate it automatically. Okay, now what has happened is I have changed this M10 to M9 value. You will see the same change in the assembly as well as the part. Now this is called as associative nature of a 3D CAD software like Creo, which you do not get, which at the advantage of this is not available in case of a software which is 2D in nature. Okay, this is one of the advantage of having this 3D CAD software. Okay, and then we'll go for model centric. What is model centric concept of a 3D CAD software? See, now this is the time where we use soft analysis softwares. Okay, there are which we also call as FEM, finite element modeling. Okay, we use finite element modeling softwares which are available, which are used for meshing purpose, and then for finite element analysis softwares which are used for analysis purpose. Okay, now when you use when you want to do any analysis, you use models, whether it is a single part, you want to do analysis on a single part, or you want to do analysis on a single on an assembly, an entire assembly. Model acts as a center of everything over here. What does that mean? If you have done a analysis of a single part or an entire assembly, after analysis you come to know that you need to update certain changes so that you can make the part better in design. You cannot do it at analysis level or meshing level. You have to come back to the original model, make those changes to that model. Okay, then those models need to be reworked, remeshed and reanalyzed to see that whether the changes that you have made or conceptualized, the changes have actually given you the result that you are expecting. So everything happens around the model which you have created. It can be an assembly model or it can be a part model. Okay, uh, nowadays models are not only used for meshing and analysis purpose. There are something called as uh, core modeling. For example, in foundries, they use this in foundries where they create cores using models, castings in short, and in even plastic models or casting models. Okay, so if they what they do is they use a casting model. They create two halves of the core. Okay, they create all the vents, whatever, everything where they are going to fill the fluid, which is also called as molten metal. Okay, and then they check whether the mold is getting filled properly or not. If not, either they have to make changes to their core or they have to make changes to the model. Okay, Most of the time it's the model that controls the core and वगैरह everything. So you have to come back to the model and make changes, and then go back again and work on your core, whether it's a plastic molding process or a casting process. Okay, whether it can be a sheet metal work also. So your model in 3D CAD software, your model acts as a center for everything, and model from model onwards you move forward for further processes. Hence, a 3D CAD software has a concept called as model centric concept. Okay, so I hope I have tried to explain you why models play as a center of entire process in a 3D CAD software, and this is a differentiating factor from 2D to 3D CAD softwares like Creo. And last thing is, in a 3D CAD, in a 2D CAD software, you have only one file called as drawing file, .drw or .dxf, whatever, depending upon what type of 2D CAD software you are using. But in 3D CAD softwares, you have minimum to maximum three files. Okay, if you have created only a part, a single part model, okay, like this bolt, then you have two softwares, two extensions, that is .prt. .prt starts is the file extension for part drawings, part models, okay, and .drw is the file extension for drawings. In Creo, specifically I'm dealing with Creo, it will be these two will exist even for other 3D CAD softwares, but their extensions may be different. Their dot extensions may be different. For Creo, in case of Creo, for part it is .prt, and for drawing it is .drw. Okay, so .drw will be the drawing extension of this part, and .prt is the extension of the part. Okay, and for assembly, for example, if you have created a drawing out of assembly, then .asm is the file extension for the assembly, and .drw will remain common for even for assembly drawings also. So in short, we have three file extensions for Creo, that is .prt, which stands for parts, .asm, which stands for assembly, and then .drw, which stands for drawings, whether it is a part level drawing or a assembly level drawing. Okay, so these are the concepts which have created a difference among 2D softwares and 3D CAD softwares. I have been using Creo for a very long time, guys, so I'm more familiar with Creo rather than any other CAD software, and all my future tutorials which I will create will be from Creo itself. Okay, I don't my company does not have any other software, we use Creo here, so we will be creating tutorials on Creo itself, and I'll be sharing it with you, so that you have better understanding of what is Creo, why it is called a parametric software, why what is its difference from a 2D software. Okay, so I hope I have cleared one of the important doubts. I will remind it again to you all. 3D CAD software like Creo here are based on six concepts which are not available in 2D software CAD softwares. They are solid modeling concept, feature based concept, parametric concept, associative concept, model centric concept, and its extensions .prt, .asm, and .drw. Okay, so that's all about the basics of Creo and what is Creo and what is a 3D CAD software and how it is differentiated from 2D CAD software. In future tutorials, we will go ahead and discuss more about the Creo basics before we actually ahead in go ahead and start doing modeling work. Okay, and I have just created a small model of bolt to show you how it happens over here. Okay, thank you guys, thank you very much, and that's all for now. Wait for my next tutorial to come up. Thank you.